In today's lesson, we will be looking at inverse functions. Specifically, you will be able to find the inverse of a function and state the domain at the end of this lesson. You will also understand why you have to restrict and how to restrict the domain to find an inverse of a function in which the inverse is in fact a function. In this example, is the inverse a function? Well, here's our regular function, y equals x squared, and drawn below is the inverse of y equals x squared. Remember that the inverse is a reflection of the original function over the line y equals x. In other words, the input x and the output y have been switched. Well, if you'll notice, our inverse would not pass the horizontal line test. If I were to draw a vertical line test, it does not pass the vertical line test. It intersects the function in two places. Our original function is not a one-to-one function because it doesn't pass the horizontal line test. Our original function is a function because it does in fact pass the vertical line test, but because it doesn't pass the horizontal line test, it's not one-to-one, which makes the inverse not a function. And we can't have that. So how do we deal with that? Well, if you'll notice, the reason it doesn't pass the vertical line test is because it crosses both the top leg and the bottom leg. In order to handle that, we do something called restricting the domain. When we restrict the domain of our parent function, what that's saying is we only want to look at half of the function. So we only want to look at either the right leg in the positive x territory or the left leg here in the negative x territory. So let's go ahead and get rid of this leg. We do that by saying that x has to be greater than or equal to 0. That's our domain restriction. So if we only reflect this part of the leg, then we only get the orange part of the leg, and this part is no longer there. Now what we have is an original function that is a one-to-one function, and therefore our inverse is also a function. Now how do we find the inverse? In order to find the inverse algebraically, we'll follow these three steps. These are important to write down in your notes in case you don't remember those from an earlier math class. The first step is to switch the input and the output. So we would just switch the variables x and y. And then we'll go ahead and write the function in terms of x. So we'll solve the function for y. Finally, so that we know it's an inverse, we'll write it in function notation. We'll replace the y with f inverse of x. We also want to identify domain and range of our inverse and of our original function. So we have a trick that we can use. We can find the domain of the function and the inverse. Then we take the domain of the function, and that becomes the range of the inverse. And then we take the domain of the inverse, and that becomes the range of the function. The reason we look at domain is because domain is easy to find. On the other hand, range is more difficult. So let's look at our first function. This is a rational function, and we just finished a unit in rational functions. So what is our domain here? We know that our domain is going to be everything but positive 1. So our domain in this case cannot be equal to 1. Let's look at our domain of our inverse function. In this case, our denominator here cannot equal 0. So our domain cannot equal 0. Otherwise, we have an undefined function. Once we have that, it's really easy to find the range. Remember that to find an inverse, we just switch x and y. So our domain is also switched, x and y. So our range in this case is going to be that y cannot equal 0, and for our inverse function, y cannot equal 1. And we can verify this in this situation because I've given you simple rational functions. In other words, we don't have a variable in the numerator, so we can look at this and we can find our vertical and our horizontal asymptotes, which helps us to find the domain. If you'll notice on the end here, there's nothing, so we assume it's plus 0. And that's how we know what our range is not going to be equal to 0, because we're going to have an asymptote there. We're also on this one going to have a horizontal asymptote at y equals 1. So our range means that all values will work except for that one. Now let's go ahead and practice finding the inverse. Here's our example that we just looked at. So here's our function. If we follow our steps, then we know that our first step is going to be to rewrite the function with x and y reversed. So we would write it as x is equal to 2 over y minus 1. Then we'll need to write it in terms of x, so we'll solve for y. In order to do that, we would multiply both sides by y minus 1, and then we can cancel the y minus 1 out of the denominator, and then we can divide both sides by x. So if we divide this side by x and this side by x, what we have left is y minus 1, these have canceled, is equal to 2 over x. Finally, we can add 1 to both sides, and we have a function that's y is equal to 2 over x plus 1. Now we have our inverse, and to represent our inverse, we would write it in inverse notation. F of f inverse x is equal to 2 over x plus 1. We've already defined our domain and range for this function, so let's move on to the next function. In this case, we have x squared plus 1. We know that if we were to graph that, it would make a parabola, and that's not a one-to-one function. So notice that we have a domain restriction. Our domain is going to be that x has to be greater than or equal to 0. So let's go ahead and find the inverse. Pause the video and go through the steps and see if you can find the inverse. So remember, step 1, switch x and y. Switch our input and our output. Step 2 means we need to write it in terms of x, so we'll solve for y. And in this case, we are left with x minus 1 equals y squared. Finally, we need to take the square root of both sides. When we do that, we get y equals the square root of x minus 1. Remember that normally when we're taking the square root of x, when we're solving, we would say plus or minus. But we're only going to use the plus because x has to be greater than or equal to 0. Last step, we'll go ahead and write this in function notation. So f inverse x is equal to the positive square root of x minus 1. Let's look at the domain and range now for this second function. So we have our function and we have our inverse. Our function's domain has already been stated for us. X has to be greater than or equal to 0. So we know that's going to be the range of our inverse. But let's think about our inverse. What is our domain of our inverse? Well, we have a radical here, so we know that x minus 1 has to be greater than or equal to 0. So if we solve this, we get x has to be greater than or equal to 1. So we'll write this in here. X has to be greater than or equal to 1. And now we know that all we have to do is switch this for our range. So our range of our original function is that y has to be greater than or equal to 1. And for our inverse, we know that x has to be greater than or equal to 0. Let's look at this graphically just to make sure this is correct. So let's look at our function first. Domain has to be greater than or equal to 0, and our range has to be greater than or equal to 1. Here's our original function in red, and you can see that I've put it over here with our domain restriction. So our domain has to be greater than or equal to 0, which it is, and our range has to be greater than or equal to 1, and since it starts here at 1, it is in fact greater than or equal to 1. Let's look at the inverse. So here's our inverse function, the square root of x minus 1. Now, just to point out, if I were to type in a negative in front of the square root and type x minus 1, notice that we would get this bottom leg, but we're not taking the negative due to the domain restriction. So we won't have this function. Let's look back at the domain and range of our inverse. Our inverse function says the domain has to be greater than or equal to 1, and the range has to be greater than or equal to 0. If we look here, the domain is in fact greater than or equal to 1 as it starts here at 1, and the range starts here at 0 and it goes up forever, so greater than or equal to 0. So at the conclusion of this lesson, you now know how to find the inverse of a function algebraically, as well as state the domain and find the range. You also understand how to restrict the domain of the function in order to make sure that our inverse is in fact a function as well.